Hello, this is Chris Chappa, and I'm bringing you the solutions to all three logic puzzles during Math Month in November of 2024, with explanations on how to solve them. The first of which was the islands in the stream puzzle, in Japanese known as Nurikabe. The goal was to shade some squares black so that each number belongs to a group of white squares. The number in a white square, the number counts the white squares in its island. All squares in an island must touch horizontally or vertically. Every island must contain a number, and every number must belong to an island. Different islands cannot touch horizontally or vertically. Diagonally is okay. All black squares must be connected, and there could be no 2 by 2 blocks of black squares, no pools. The solution is unique and requires no guessing. The hint that I gave is that a 1 must be surrounded by black squares, and if a square is adjacent to two numbers, it must be black. Remember that all black squares must be connected. Look for trapped black squares. Let's take a look on how to solve this. I'm going to be using Paint 3D because it allows me to easily fill in squares. All right, so instead of using black for the squares, because I don't want the black to overrun the black lines, I'm going to use let's use blue for the squares since they're representing a stream. So we're going to start by filling in everything we can, starting with the ones. Each one belongs to its own island, so it has to be surrounded by water on all four sides. So instantly we can go to, and this is one of the hints that I gave. The other hint that I gave is that if there's a square that's adjacent to any two numbered squares, it must be black. It must be water. For example, take this square next to these two twos. If we were to shade the twos yellow to represent land, then putting a land here would connect these islands and make it too large. Every number belongs to one island, and every island has one number. So the strategy of looking for squares that are adjacent to two numbered squares is critical. Any square adjacent to two numbered squares is must be water. So this square is adjacent to the two twos, as is this one. This square is adjacent to the two twos. There's two types of adjacency, either in the same column here or the same row, or diagonally adjacent. So anywhere you see two numbers in not necessarily consecutive squares, but two numbers in a row or column that have one square between them, that square must be water. And if you see two numbers that touch diagonally, both squares that touch them must be water. I believe we found all of the squares that are adjacent to two different numbers. Okay, now we start looking for things that are trapped. Remember, all the water has to connect. If you look at the top right corner, this blue square in water, if we were to put land next to it, then that water would be trapped and could not join the rest of the stream. So every trapped blue square has to escape to eventually connect to the other blue squares. Now, at this point, I don't know which direction this blue square goes, so I'm done with it. But we can also look for trapped numbers. For example, this 2 is trapped and it must be part of a 2-square island. So if it must extend outwards and that will complete the island. Once you complete an island, you can completely surround it by water horizontally and vertically. And this goes back and forth between finding trapped land and trapped water. For example, this 3 belongs to an island of 3 squares, and the only direction it can go is downwards. That would complete the 3, so we surround it by water. The 2 on the top center, the only direction it can go to complete its island is to the left. That completes it, and it's surrounded by water. If you see an empty square surrounded by water, it must be water. It can't be land because if it were land, it would only have one square and would have to have a 1 there because every island has a number. So any square completely surrounded by water on four sides is also water. The 2 on top is also an island that is trapped and must go to the left, so we can surround that island. And we might as well go ahead and color all the islands yellow. Normally you don't have to do this. I'm just doing it for explanatory reasons. Just remember that all the water must connect and no two islands can connect horizontally or vertically. And then you start looking for trapped things. On the top, this 2 is an island that is trapped. It must go downwards. So that would complete the 2 island. You surround it by water. Here's a square that is completely surrounded by water, so it must be water. Now here's the first instance of a 2 by 2 pool. You cannot have a 2 by 2 block of water, of blue squares or black squares. So there's no way that can be blue. That would violate the rule of the 2 by 2 square of water. So that has to be an island. This stream up here is trapped. This 7 shape must escape this direction. Going on the bottom, this stream is trapped and must go to the right and up to join the rest of the stream. This traps the 8, which must go up at least twice, which subsequently traps the water again, which subsequently traps the 8 again. This 3 is trapped and must go up. That traps the water, which traps the 8. And by the way, this is not the only order in which you can do these things. You just look for something that must happen. If there's a choice, then you're not looking at the right place. You look for places where you don't have choices. Here's a new phenomenon that sort of hasn't happened yet, but this square right here can't be yellow. Why not? Because if it were, it would connect the 4 and the 3 islands. So that square has to be water, which traps the 3 island, so it must escape upwards, but that completes the 3 island, which means we surround it by water. This stream is trapped, it must move upwards, and it looks like we're going to be able to complete the 8 island with this stray piece of land. We have a square completely surrounded by water, so it must be water. That creates a potential 2 by 2 pool here. That can't happen, so this corner must be land. This 2 has to escape to the left. That completes the 2 islands, so we surround it by water. This square is surrounded by water, so it's water. Now we got all kinds of places to go. This 4 island must go to the left to continue. It cannot go to the right, to the left any further because it would join up with the 5 island. Or we could alternatively say this must be water. That forces the 4 island to go up and completes it, so we surround it. Then the 5 and the 4 are both trapped and have to escape. But they can't join up, so this square can't be yellow, so that has to be water. That forces the 4 to go to the left. And at this point, we seem to be at an impasse because there seems to be no other places where we must make choices. For example, this 4, we don't know if it goes to the left or up. This 5, we don't know if it goes to the left or up. And we don't know where the 3 goes. Nothing is currently trapped, neither water nor unfinished islands. So we have to use a new technique. The technique is basically there are some squares that can't reach islands. For example, look at this square here. If it were going to be part of an island, which island would it be part of? Well, it can't reach the 3 because then that would be a 4 island. And it also can't reach the 5 because that would be more than a 5 island. So that red square can't be land because it's too far away from any of the numbers that are available, which means it must be water. Is there any other square we can do as such? Yes, this one. Why? What if it were land? Could it connect to the 3? No, that forms a 4 island. Could it connect to the 5? No, that forms a 6 island. So that red square also is out of reach for any of the remaining numbers, so it must also be water, which creates 2 possible 2 by 2 pools. One here, so no water here, must be land, and one here, no water here, must be land. Both of these lands have to eventually escape and hook up with numbers. The one on the left hooks up with the 3 and completes the 3 island, which subsequently lets us complete the 5 island, which means we can surround the 5 island with water. And now we have to make a choice on where to put the last square of the 4. Can it go here? The answer is no, because if it did, then we would have to surround it, and that would create a 2 by 2 pool. So putting a land there is incorrect, which means it has to be water, which forces the 4 to go up, completing the 4 island and connecting all the streams. And there's the solution to the islands in the stream. Now, let's take a look at the second puzzle, which was the Akari puzzle. Here it is. Also known as light up. I know it's pronounced Akari because I have a Japanese student to tell me that. And Akari is Japanese for light. The goal is to place light bulbs in certain white squares to illuminate all white squares. A cell is illuminated by a light bulb if they're in the same row or column, and if there are no black cells between them. Also, no light bulb may illuminate another light bulb. Some of the black cells have numbers in them. A number in a black cell indicates how many light bulbs share an edge with that cell. Hint, use a circle to represent a light bulb and a small dot to indicate a square illuminated by a light bulb. I'm actually going to use a slightly different protocol for representation here. Let me go into the puzzle in Paint so that we can play with it. I'm going to represent squares that cannot have light bulbs with a red dot. So for example, the zeros, they can't have any light bulbs around them. Now, when I've completely represented all four sides of a numbered square, I'm going to cross it out just as a reminder that I'm done with it, because sometimes you get so into a puzzle you don't remember which numbers you've used, which ones you haven't used. Now, big numbers are good too, such as this 3. This 3 means I have to have 3 light bulbs adjacent to it. There are only 3 white squares adjacent to it. So I'm going to put a light bulb in, and we'll do a little bit better job than that. We'll put a circle. How about that? We'll put a light bulb inside of here, and we'll make sure that it is um, the color that I want. We'll make the light bulb orange. And then we will paste that into all the spots around it. Oops, where'd it go? There we go. All right, so that completes the 3. So let's cross it out. We'll cross it out with a little red mark. But when you place a light bulb, it's going to illuminate every square that it sees horizontally and vertically. So we're going to fill in all the squares that the light bulbs see, including the squares themselves. This light bulb sees the squares above it and to the left of it. It's blocked on the right and below by black squares. The light bulb on the bottom sees its square and the one to its right. And the light bulb on the right sees itself and everything below and above it. So we want every square to be lit up. And then we just go back and forth between where we can't have a light bulb and where we must have a light bulb. For example, look at the 1 above the 3 that is currently crossed out. There's only one square available to put a light bulb in it. Remember, light bulbs can't see each other, so I can't put a light bulb here because that would see the one below it. Once the square is shaded, it is ineligible to have a light bulb. The only square left to have a light bulb around the 1 is the one above it. And the minute we put that there, we can cross out the 1. We can cross out the 1. Okay, that'll work. But I'm going to be OCD about it. And we can shade in, we can highlight, we can illuminate all the squares that this light bulb sees. The square above it and the square to the left of it. Squares to the left of it. Let's see, are there any other places where we have no choices? Because this is a game of where we're forced to do something. At this juncture, I don't see any other numbers where we're forced to put a certain light bulb in a certain place. So I need to introduce a new trick. And the trick is when you have one more square available than the number in the box. For example, look at the 2 in the upper right corner, the 2 that is currently right here. Okay, well, it's that 2 right there. So how many squares are available around this 2? There are 1, 2, and 3. Now, why is it relevant if there are one more available squares around a number than the number itself? The reason it's relevant is because the corners touching that number may not be able to have light bulbs. For example, what would happen if we put a light bulb here in this corner? If we put the light bulb in that corner, then it would illuminate the square below and the square to the right, to the left, which would not leave enough available squares around the 2 to place a light bulb. So if you see a square that has one more available square around it for light bulbs than the number itself, then examine the corners. Now this corner over here that I'm about to put a light bulb in, this one would be okay, because if we put a light bulb there, it would not cross out too many of the squares around the 2. I can still put 2 light bulbs around it. So if there's a corner to a number that a light bulb would cross out too many squares around the number, then there can't be a light bulb there. So translation, or long story short, no light bulb here. Now there's some other places we can do this. This 2, well, it's already taken care of with that dot, so I don't have to worry about that. This 2 only has 3 squares around it. I can't put a light bulb in this corner because if I did, it would kill off these 2 squares and there wouldn't be enough squares around the 2 to put a light bulb. So no light bulb there. This 2 down here has 3 squares around it, so there cannot be a light bulb in either of these. It would kill off too many of the squares around the 2. And the same thing with this 2 here. There's only 3 squares available around it. Remember, if it's yellow, we can't put a light bulb in it anymore. So no square here, no light bulb there, and no light bulb there. All right, are there any other numbers where we have issues? Yes. Now this 1. Notice this 1 only has 2 squares available for light bulbs to the left and below. If we put a light bulb here, it would cross out both of those, and there would no longer be a square available for a light bulb, which means there's no light bulb here. Just checking something real quick. Okay, I don't have to resort to that trick anymore because I now see a number where I'm forced to put a light bulb. Do you see it? Look at this 1. Based on the analysis so far, there's only 1 square available for its light bulb, and that is to its left. So let's go ahead and cross out this 1 and set up the light bulb to its left. And then illuminate all squares that this light bulb will see. It sees itself, everything to the left, everything above, and everything below. Now, anytime you gather new information around a number, you should check it out. For example, this light bulb just illuminated the square below the 1. Now this 1 only has 1 available square for its light bulb to its left. Let's go ahead and cross out that 1 in anticipation of putting the light bulb to its left. And now that we've got the light bulb there, let's illuminate all the squares that it can see. It sees itself, the one below it, the ones to the left of it, and the ones above it. Aha, that tells us this 2 must have 2 light bulbs to the left and below because we just crossed out the 3rd square, or we just eliminated it because that 3rd square to its right just got highlighted. So let's drop the light bulbs here. By the way, that will also complete the 2 below it, or the 2 diagonal to it, I should say. So let's go ahead and cross out this 2, and let's illuminate all the squares with light bulb C. This 1 sees itself and everything below it, and to the right, but it was already lit. This 1 sees itself and everything to the right. Oh, and because we just crossed out that second 2, then we can say no light bulb here. All right. Is there any other number where we can know things? Yes, look at this 2 down here. Of the 3 squares, one of them is illuminated, which means the other 2 must contain light bulbs. So we'll go ahead and cross out the 2, and we'll put the light bulbs to the right of it and below it. And then highlight, or rather illuminate, all of the squares that those light bulbs see. This light bulb sees itself, the square above it, the square below it. The one to the right is already illuminated. And the light bulb on the bottom sees all the squares to its right and all the squares to its left. Okay, now let's inspect the numbers that we don't have crossed out yet to see if there's anything we can do. This 1 still has 2 possible places for its light bulb. This 2 still has 3 possible places, as does this. So at this point, it doesn't look like we can place a light bulb based on the numbers that are available. However, here's a new trick. At some point, an unilluminated square will have no choices on how it can be illuminated. For example, let's look at this square here. Let's look at that square there. Okay, this is freezing up on me. Let's look at this square right here. How can I light up that square? Well, I can't place any bulb above it, to the left of it, to the right of it, or below it to light up. So the only way I can light up that square is to actually put a light bulb in it. There are no other squares available that can illuminate it, so it must illuminate itself. That means that I can cross out the 1 because I found its light bulb, which means no square here. Do you see any other squares where we have no options on how to illuminate them? I see at least one. And right now, I think I see only one. No, actually, I see two. The one that I saw first was to the right of this 2, because look at this square right here. What can illuminate it? Well, I can't put a light bulb above it, to the left, to below, or to the right. So the only way that square can get illuminated is if I actually put a light bulb on it, which would subsequently illuminate itself and the square above it. But are there any other squares where there are no choices on how to illuminate it? I see 2 squares that have no choices, both that can be illuminated by the same light bulb once we place it, and that's these 2 squares down here. Look at this square. Where's the only square available that can illuminate it? There's none above, none to the left, none below. And if you look to the right, the only square available is this one. This must be a light bulb. It's the only way both this square and the one to the left can be illuminated. So now we're down to I must have a light bulb because some squares have no other option on how to be illuminated. So that illuminates itself, the 2 squares to the right, and the square above it. And since I just illuminated the square above it, which is adjacent to the 2, that gives me information about the 2. There are only 2 squares available around the 2 that I can put light bulbs around. So I'm done with the 2 because I'm going to place a light bulb above it and to the left of it. And illuminate the correct squares accordingly. The one above it will illuminate all the squares above it, the ones to the right and the one to the left. The light bulb to the left of the 2 will illuminate that square, the one below it, the ones above it, and the ones to the left. At this point, we're almost out of options on what to do. For example, these 2 squares on the left, the only way they can be illuminated is by this square below them. So we're going to put a light bulb there. We'll put a light bulb here, which will illuminate the square that it is in and these squares above it. This square below the crossed out 0 can only be illuminated by this square to the right of it, the one under the 2. So we must have a light bulb here, which will illuminate itself and the square to the right, to the left, excuse me. Notice that this puts the second light bulb on the 2. So we are done with the 2 and cannot have any more. Let's make that red. We are done with the 2 and cannot have any more light bulbs around it, including above it. And you could probably figure out that the last remaining light bulb to illuminate the rest of the squares must go right here, which would illuminate the squares to the left and to the right and itself. And we have found all the light bulbs that none of which can see each other. Each number has the correct number of light bulbs around it, and every square gets illuminated. All right, we're going to try to get the last one done soon. I actually have a class not too long from now, but maybe we can do this fairly quickly. The last one was the Slither Link puzzle. Without going into all the instructions, we have to draw one continual loop that closes itself, one closed loop, and each number represents the number of segments within a square that are used in that loop. The obvious place to start, or at least I think, are the zeros, because zeros can have no segments around them. Now, I've already put some X's around the zeros there. For the sake of convenience, I'm going to use dots. I'm going to use red dots to indicate no segment there. And of course, 3s are good as well, because if you see a 3, like right here, with one of its sides crossed out, then the other 3 must be part of the path. And the path must continue, so when you have no choice, continue it in a certain direction. We can do the same thing down here with this 3. and the path must continue. Now, a strategy that is incredibly useful that it's not mentioned in the instructions is every dot in the picture is either used no times or exactly twice, because either the path doesn't go through it or it does, meaning it has to go in and then out. So of the 4 segments emanating from a dot, you either use none of them or precisely 2 of them. This is important because if you have a path that goes through a dot, in and out, you've used 2 of the 4 segments, which means the rest of the segments emanating from that point are dead. So anytime you go through a point in and out, you can immediately cross out all the other points that connect to that part of the path. Like up here, I can't have a path there or there or there or there. Let's go back down here. Notice that this dot means that I have to complete the 3 that way, and the same thing here. I'm going to cross out the numbers as I use them to remind myself that I don't need to worry about them anymore. Here's another set point that the path goes in and out of, which kills the other 2 segments attaching to it. That forces these 2 to become part of the 3. And then the path must continue to the left. That uses up the 1, which means the 1 is done. And now the 3 must use all 3 of these segments. So the 3 is done. And the path must continue upward and to the right. Every time you go through it in and out of a dot, you can cross out the other 2 segments that would connect it. This 2 needs a second square segment here. That completes the 2. And I'm forced to do the following. I can't close the loop too early, so don't connect there. Don't connect there. Don't connect here. Don't connect here. Now look at this 2. I've only got 1 place left. Done with the 2. I've used this dot, so let's kill the rest of the segments around it. I've only got 2 places left to complete this 2. Notice I'm not guessing anything. I'm simply marking where I must or must not have a line segment. Use that dot. This dot is used. This dot is used. This 2 only has 1 segment left to go. That completes this 1, so dots around there. Segment must go this way, must go that way. I've used this dot here. That means I've only got 1 segment left for this 2. And the more you do these, the easier this becomes to see. This path must continue upward. That completes the 2, so we're done with its square. This path must go up. This path must go to the right. And again, these aren't the only places I could go. It's just where I'm looking right now. This path must go upward. That completes the 1, so the rest of its segments are dead. This 3 only has 3 available segments left because I just crossed out one of its sides. Path must continue. This dot is done. And here's something we haven't seen yet. If you see a dot where 3 of its segments are crossed out, then all of its segments are crossed out because you either use none or 2 of the segments. There's only 1 segment available. So we'll put a dot there, which means the only segment left for the 2 is this. Crosses that out, uses this dot up. Now the 3 has to do this, which uses up both of these dots. And the 3 and the path must continue. Okay, that's the top of it. Make sure I wasn't missing something. We use this dot so we can cross out its segments. We use this dot so we can cross out its other 2 segments. This 2 must have a segment here to complete, and that forces it to go up. Let's see. This dot is dead. It's only got 1 segment left. This 2 only has 2 segments left. So it's gone. I've used this dot, and I've used this dot. So both of these 2s only have 1 option on how to complete them. Path must continue up. I've used this dot, so the rest of it is dead. The only segment left for the 3 is here. I've just used 1 segment on the 1, so the rest of its segments are dead. There's only 3 segments left on this 3. I've used up this dot. There's only 2 segments left on the 2. And I know this is going kind of fast, not the least of which reason is I have a class soon. But every time I complete a square, I should cross out its number. You don't have to, but it's not a bad idea. And every time you use up a dot, you should eliminate the rest of the segments connecting it. And eventually you start seeing that you don't have as many choices as you think. I've used the 2, so a dot here. This goes down, this goes down. I've used the 2, so a dot here. This goes down, this goes over. Let's see. This path must go down. I've used that too, so that square is complete. This must go down and must go over, which uses the 2 and puts a dot here. This goes over, this goes over. And here's an instance where if we went across, we would close the path too early. That would close the path too early, so that can't be a segment, which forces them down here. Let's go back here. We use this dot so we can eliminate the rest of its segments. That forces this 3 to do this, so we're done with the 3. We've used this dot, so that kills the rest of its segments. This segment has to go up and up again. That kills this dot, so this 2 has to have these. And this 3 has to use these because it's already got one side killed. I've used a lot of dots, so let's go X out all the segments that could connect them. And then up. Let's see, this segment has no choice, it must go up. Let's see, there's a dead dot here because it's got 3 of its 4 segments used. That means I've only got these 2 segments left for the 2. I've used this dot so I can cross out the rest of its segments. That leaves 2 segments for this 2. I've used these dots so I can cross out those segments. This must go to the left. I'm done with that 2, by the way. Let's see, this segment must go to the right. I'm done with this 2. Cross out those. This path must go downward. I have a choice here, so I'm not ready to make it yet. Let's see. Trying to find any other things that don't require new hints. Okay, here's another one. If you're on the edge, if you're a dot on the edge, you don't have 4 segments that connect to you. You only have 3. If a path goes through it, it must use 2 of those segments. Think of it as this dot has a dead segment on the right because it can't go over there. So this dot is now dead, which means this 2 must go over here, and this path must continue upward. This segment's dead because of this dot here. This must go to the right, which kills that segment. The 2 must go this way to complete the 2. That kills this segment. The 3 to complete has to do this. It can't go to the right because it would dead end, so it must go to the left. It can't close too early, so these both must go to the left, and it still can't close too early, so this must go to the left, and my only option up here is to continue. I can't close this loop too early, so down, down, and I think we have it. There it is. I love these puzzles because they're completely logically solved. There's no guesswork that has to be done. The more complicated puzzles force you to look for more hints implied by the structure of the puzzle. But these are just some of the basic ones. I hope you've enjoyed them. And if you have any questions, just let me know.